All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD or Application and Website Development 1100 C# programming class, I've been doing a couple, I don't know what you'd call them, kind of preliminary lectures on the stuff that we're going to be handling in class. So far, we've done the first 6 chapters, and I'm going to go into Chapter 7 now, which talks about how to handle exceptions and validate data. All right? So we'll get an introduction to exceptions and exception handling, how to use structured exception handling, how to validate data, and then adding some data validation to our future value app. Okay. So I've said this kind of thing before, and I want to say it again, that an exception in programming means an exception to the norm. Again, I've said this kind of example before. If you, let's just say you and your significant other have a child, and you're walking, you're walking your child in a stroller in a park, and somebody comes by and says, "What an exceptional child," you'd probably say, "Thank you." But in programming terminology, an exception is an exception to the norm. It's not a good thing. All right. And what they say here is sooner or later you're going to probably run into a case where you're going to have some kind of an exception that's going to happen. Something that isn't meant to be happens. There's 3 ways that you can handle this. Number 1, I call it the ostrich method because you duck your head, and cover and hope that it never happens. So in other words, you don't plan for it all. You just take for granted that whomever is going to be running the program, they'll know what they're doing. That's the worst way to handle it. The second way is how we've been handling it thus far. That is, we're never letting bad data into the system to begin with. We're using if statements, while loops, etc. to keep bad data out. The third way of doing it, and what's discussed in this chapter, is letting the data in and then handling it after it's in. All right? So as it says here, a well-coded app will catch exceptions that might be thrown and will handle them. That is exception handling. How you're handling them depends on the severity of the error. For example, if we're working with a database, which we haven't talked about yet, but if you're working on a program with a database or a file, let's just say you're working on a program with a file that's got data in it that you need, and you can't open the file, then the exception, the way to handle it might be to stop the program, because if you don't have the information, you can't go on and do anything. All right. When you're testing an app, it's common to encounter exceptions that you didn't think about. All right. All exceptions, as it says, are subclasses of the exception class. And there's several of them. There's a format exception, all right, that occurs when you can't convert data from one type to another. There is an arithmetic exception that occurs when you're doing something you probably shouldn't be doing. There's an overflow exception when it's the equivalent of trying to shove 10 pounds worth into a 5-pound bag. There's the divide by zero exception. We talked about that with the calculator program. Okay, it says for now, basically they've told you kind of what you need to know. All right. And all exceptions are part of the exception hierarchy. So all of them are exceptions. So an arithmetic exception is a child of exception. A format exception is a child of exception. An overflow exception and a divide by zero exception are both children of an arithmetic exception, etc. So when you're converting data, as an example, as shown right here, there's a time when you might end up having to worry about exceptions. When you try to convert something and it doesn't work the way you want it to work. All right? So, displaying a dialog, how you handle the exception is up to you. Here they're talking about doing it with a message box. That's fine, but then what do you want to do after that message box shows? That's always up to you as a programmer to see how you want to handle it. All right? So it says in Chapter 10, guess what? We've already talked a lot about message boxes. So All right, using structured exception handling. So as it says there, to prevent your apps from crashing, you can write code that handles exceptions when they occur. This is known as structured exception handling. All right, so they're going to show some, and it all evolves around what's called a try-catch, and really it's a try-catch finally block. What you put underneath the try in the curly braces is code that could conceivably fail. You can have one or more catch areas. All right, and they have to be from the most specific type of error to the most general type of error. And once, if you try something and it fails, as soon as the system finds a catch that will meet its criteria, it does that, and it skips every other catch. You can't be in a catch and say, hey, go back here and then I try again because I fixed it. You can't. It doesn't work like that. So as they mention here, you can use a try-catch statement to code an exception handler. You can code a try block around any statements that can throw an exception. There's also a finally block that's in here, and what the finally is typically is used for is for cleanup type of operations. All right. Some of the things that are related to this, when you've got a try and a catch, you can print out in the catch the message, and that's got the information about the exception, and a stack trace if you want to show what information or what method or methods were called coming up to when this thing failed. All right. You can catch, again, as I mentioned, specific types of exceptions. So when we're looking here, what we're saying is a format exception is more specific than an overflow exception, and these are both more specific than a regular exception. Remember, you've got to have the most specific exceptions at the top, and they should get less and less specific or more and more general as you go down towards the bottom. And again, you can put a finally block after your last catch block. You can have just one catch block. You can have multiple catch blocks. You can throw an exception yourself if something happens that you don't want to have happen. You can throw a new exception. We'll look at that in just a couple minutes. So the future value app with exception handling. Well, so far we've handled it all by using if statements. But here, notice everything is in a try-catch. So if you try and you've got some kind of a format exception, it'll be caught there. If you try and you have some kind of an overflow exception, it'll be caught here. If you try and you have an exception that's not a format or an overflow, it'll be handled here. So there's a lot of different ways that you can handle this stuff. And going along with this is the whole idea of data validation. You can validate as much or as little as you need to validate in a programming example. We've done some of this already. We have validated, for example, if you remember in earlier programs, we validated to make sure that the amount of or that the grade that we gave to somebody was greater than or equal to 0 and less than or equal to 100. That was a validation check. You can validate for a range, like I just mentioned. You can validate that an entry has been made. You can validate that it's the right type of entry. So there's a lot of different things that you can do. Now, they're giving here these code methods: is present, is decimal, is within range. These are things that you're going to end up using a lot as we go on in here. All right. So what I'm going to do is I'm going to incorporate these into an example that I'm going to write in just a couple minutes. It's going to go through this stuff. All right. You can validate, like I said, one thing or many things. And here's the future value app with some data validation. So again, when we look at the code in here, what you'll notice is there is an error, and here is that message that went with it. So you can see what happened. Here is the system message. That's probably our own message, and there's the system message. Now we can look at that one as a class, that's fine. But let's go back, all right, because this lecture has not been very long. But before we go on into chapter 8, which is on using arrays and collections, which is, are their own little animal, all right, let's go in and let's go back to this, okay, and let's write a routine or write a program that's going to incorporate this stuff, all right. So I'm going to go back out here. I did pretty up a little bit the calculator program, the one that I did that was a console app. So it looks like this now. Enter a number 567, enter another number 21. Gives you the stuff. Do you want to run the program again? And if I say yes, it does it all over again. And if I say no, it stops. It's not a bad looking program now. So we were going up and up with this. So I'm going to make another test project here. It'll be test project 4. So let's add a new project. Again, it'll be a Windows form. And it'll be a Windows form, .NET Framework. And we're going to call this again test project 4. All right. And it'll come up in just a moment, hopefully. Well, I think I added the wrong kind of project in here. Looking at this, I did. So let me remove that. And try it again. First, let me close everything that's here. That's on me for not doing that earlier. So, all right. So let's come in, add a new project. Again, Windows form, .NET Library Framework, .NET Framework. Windows Form App, .NET Framework, C#. I think that's the right one. And I'm going to try. Sometimes after I remove this, if I come in here and put in test project 4, it may give me an error here. It says that it's already there because some of the system files were there. So I'll just make it 4A. Okay, there it is. That's what we want. Now we're going to make a very simple program here, but it'll allow us to demonstrate some of the stuff that we've been working with. So let's start as I have been by creating the 3 buttons. That doesn't look too bad. And then we will have in here 3 labels. As always, I'm going to come in and set the auto size to false so I can make these bigger. Again, we'll have 3 of these. And we'll have 3 text boxes. Where we go. All right, so there is my interface. As always, let's come in and make a couple changes here. But let's, I haven't been doing this lately, so let's do this because it's a good idea. So I'm going to rename the form. So I'm going to call this MPG. We'll do a miles per gallon program here. And yes, I want to change it everywhere. Let's change the background color. What haven't we used yet? Not green, so let's try green. All right, so we've got that. Let's take everything that's in here and let's change our size as we've been doing. So it's nice and big, and make it 22 in bold and Arial. That looks pretty good. All right, this is going to be our miles per gallon, so this one is going to be read only. All right, this is going to be miles driven, so I will call it LBL miles driven. And I'm going to put in there, I might have to widen this out just a little bit, but we'll see. Miles driven. No, it fit. So this will be TXT miles driven. This will be gallons used. And the text, again, will be gallons used. And finally, we'll have, so that'll be TXT gallons used. And this will be miles per gallon. Let's just put in here MPG. All right, so this will end up just being MPG. And we'll make this TXT MPG. All right, let's quickly just do this. I want to move this over so that it is right justified. Right there, I like that. And I'm going to take all of this and I'm going to make sure that it's centered. These are just things I do. You don't have to do any of them, of course. All right, so we've got that. Let's do our buttons. So the first one is always will be BTN calculate. With the text calculate. The second will be have clear on it and be BTN clear. The third one will have exit on it and it will be BTN exit. As always, let's take our interface and lock it into place. There, now we're ready to go. All right, so we want to put in our code for our calculate. We want to put in our code for our clear. And we want to put in our code for our exit. And we're going to write this, because we learned this in the last chapter, so we're going to write this in a very modular way. All right, so clear, we want to clear, 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 and set the focus. So let's call this clear all fields. How about clear all inputs and outputs? So we'll call it there. We'll write it down below. It's not going to return anything, so it's a private void. And it'll be txt miles driven dot text equals nothing. Txt gallons used dot text will be equal to nothing. Txt mpg dot text will be equal to nothing. And the txt miles driven dot focus. All right, that's everything that's in there. All right, and in our exit, we'll call this exit program or not. And we will write that down here. I'm again, as always, going to grab that text that I have over here. There it is. So again, I should now be able to check my two buttons to make sure they work. Why don't we, as long as we're doing all this, I have it centered. Let's do our accept button and our cancel button. So our accept will be calculate, our cancel will be clear, and let's set the tab order. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8. Do another view tab order to make that go away. Do a save all and let's run it. Oops. Of course, we have to set that being our active project to set as startup. There that is. We'll put something there and there. Clear does clear, and it puts our cursor there. Exit, no. Exit, yes. So it's all working. So let's do the calculate now. Okay. All right. So what do we want to do? First thing we want to do, and we're going to come up here because we haven't been doing this kind of thing, is we're going to make some constants. And I'm going to call the minimum miles that you can drive is going to be equal to 1. And the maximum amount that you can drive is going to be 1,000. I'm just making these numbers up. They mean nothing. And the minimum gallons that you can use will be 1. And the maximum gallons you can use will be 100. All right, so we've got some, whoop, that'll have to have an M there, as will this. All right, so we've got our constants that we just came up with here. Okay, and let's write this routine right here. Let's see. Going back to our book, we said that we wanted to use this, is present, and is decimal, and is within range. Okay, so we want to use all those. And I'm going to write those in just a minute, but the copy doesn't work on here, unfortunately. And I might be able to grab it from the book. I don't know. But I'll just write it because it's not that much typing to do. So, there's a lot of ways we can write this. The way I oftentimes do it is in my calculate button. I'm going to come in here and I'm going to do this. I'm going to say, I'm going to make a Boolean variable that's called keep going. And I'm going to set it equal to true. All right. Also, even though this isn't great practice, since I'm not going to pass it all over the place, I'm going to make a constant decimal that's going to be called miles driven. I don't want that to be a constant. I want that to be a variable. That'll be a decimal miles driven. We'll set it equal to 0 to start, 0.0. And we'll have another one that we'll call gallons used. And we'll set that equal to 0.0 as well. It needs an M on the end, which is why I'm getting that error. All right. So let's see. All right. So that's all in there. Now we want to be passing that back and forth, even though making stuff global like that isn't really the best idea in the world. All right. What else do we want to do then? Let's write those routines. All right, the clear, we've got all this stuff, but let's write those down at the bottom here. So right down here below our exit program or not, we're going to first write this is present. I'm going to write it exactly like it is here. Like I said, I'm doing it exactly the way that it is in the book here. Okay. I'm going to say a value dot trim. I'm going to make sure I get rid of any empty spaces. And we'll put an exclamation point there. Okay. And so that is exactly what I just typed in right there. Is exactly, whoops, get that back, what you have here, except I put an exclamation point in and I ran the trim method. Okay. Then I'm going to do the next one they've got here, which is a private string is decimal. Whoops, try that again. There we go. All right, so that's the is decimal. Spelled decimal wrong. That needs a space. There we go. Whoops. All right, so that's the second one, and let's write the third one then, which is to check to see if something is within range. Oops. All right. Again, we're going to go over all of these. I promise you, we will go over all of these in, as we're going through the program. Move this over a little bit so you can see everything. Okay. Okay, and then I have to return the message. So what we have done so far in here, in addition to our own stuff, is I've added these three methods from page 219, I think it is, in the book. All right. So what I'm going to do next is I'm going to run through and actually try to put some logic in here. All right, I have to pause for just a moment, and I'll be back in just a couple minutes. All right, then, to continue on, let's see. Okay, this is what we have. And let's see. There's a lot of different ways, as you'd probably guess, to write this. We've got our clear done, and we wrote that as a separate routine down here, or here. Okay, so it's being called from here. You might even think, why are we doing that? Well, later we'll talk about menus. And the reason that you write routines like that is so you can call them from different places. In fact, maybe we'll add a menu onto this in just a few minutes. And the same thing with our exit button. It's got a routine that we're calling. So now we're going to go in and do our is decimal and our is within range and our is present. Okay? So this keep going, this Boolean, all right, we're going to set it equal to is present, and what we want to pass into is present, the value we want to pass in. Let's see how they did it in the book. I want to make sure that I'm not, let's see. So that's the name, and that's its value. Okay. So the value is going to be really it's going to be txt miles driven dot text. All right, and we'll call this miles driven. And as far as this, let's go and make these are variables. So let's use the right caseness in here and in here. And since we are passing them and they're now global, let's make them local, which is a better way of doing it anyway. Like that. And we'll pass into here miles driven. Okay. So is it present? Okay, that's a decimal value, and so we're supposed to make it a string. Okay. So we'll make this a string, and we'll say miles driven, like that. All right, so let's see now what doesn't it like. All right, well, let's look. Okay, I've got this keep going equals is present, and I'm passing in two strings. All right, I've got to answer something from Rankin here, so give me a second. All right, so is present is expecting. Let's check again. A string and a string. Okay, and we're going to say here if value dot trim is equal to nothing, it's a required field. Okay, that should be fine. So what doesn't it like here? I'm trying to figure this out. So is present, it says here, cannot implicitly convert type string to type bool. Okay, well, what is this returning? It returns a string, which has got that message in it. All right, I'm going to have to, I guess, pause a little bit. I'm dealing with an internal. All right, or maybe not. Let's change this. Instead of making this a string, all right, let's make this a Boolean. All right, It'll fix the error we had up above. Now, this is wrong because this is a string. But we're going to write another method down here. It's going to be called show message. And it'll take in a string, which will have a message, and another string, which will have a title. And what we'll do is we'll write up a message box. So a message box dot show, and it will show the message, and it will show the title, and it will also then have the buttons, and it'll have, this will actually be an error. Okay. All right. So if it's not present, if in other words, if you come in here and you do all this stuff, rather than it saying this message is a required field, which is okay. All right. We're going to pass in we're going to call show message. All right. And the message will be, in this case, miles driven is a required field. All right. And then the other parameter that we'll pass in is the title. We'll just say field required, field missing. All right, so that's fixed. Now, if that's the case, we want to say, we could say right here, return false because it's not present. Then down here, say return true. So we could have a return here and a return here. But I can also come in and create a variable, a bool that's called retval for return value, and I'm going to set it equal to true. All right, so in this case, I'm going to say right here, retval equal false because the field is not present. Now I can return retval. So now if we run this and I put nothing into the first field there, all right, required field missing, miles driven is a required field. Okay, so that worked. So let's keep going. So I've got here bool keep going equals this. Now, if keep going, in other words, it wasn't empty. So if keep going, keep going equal, and what was our next field? Our next one here was called, we had an is present. This will be is decimal. Now, don't worry, we're going to have the same problem we had before, but we'll fix it in just a minute. All right. Now, if that keep going, okay, that meant that there was nothing in there, so we'll just return. Now, we have to fix this by making this, again, another Boolean. So we'll make that a Boolean, just like we had before. And just like we had before, we'll do the same kind of thing that we did up there. I'll say bool retval equal true. And down here, I'm going to say here, just like we did, retval equal false, and we will return retval. All right, and then we'll call show message again. And we'll give it a different message. All right, so let's see if I fix that or not. Oh, we don't need this message anymore. All right, we don't need it in there. We're not using it because we rewrote this. So now if we do come in, and let me save this. And if I put in nothing, all right, required field missing, miles driven is a required field. And if I put in something non-numeric, all right, non-numeric input, miles driven must be a numeric value. I should clear that out as well, and I'm not right now, so I will. Let's see. So we did the ret val, and then we did the ret val again. If keep going, well, then what are we going to be able, whoops, try that again. If keep going, now we want to say keep going. We're going to get the same error we had before, but equal is within range. And what we want to pass into that is, again, txt miles driven. Again, we want miles driven, but now we want to add to this min miles, and we want to add max miles. Technically, we don't have to add those because text, they're global already. Okay, now let's fix this. Again, we get the same error we had before. So just like we've been doing, all right, I'm going to grab this bool ret val thing, and we're going to put that in here. We're going to make this, again, a Boolean. All right, we won't need this message, but we'll replace that with that. All right, so if that's the case, just like we did previously, all right, and we will return ret val. Okay, now, rather than saying must be a numeric value, we're going to say name must be a value between min val and max val. I'm sorry, not max val. Max miles and min miles, not min val. I'm sorry. All right. Now, let's see if we've got everything handled. If we've got everything handled now for our miles driven. So if there's nothing, it's a required field that's missing. If we put in something, whoop, I got to put the focus there, non-numeric. All right. It's must be a numeric value, and we got to remove that. And finally, if we put in something that's out of range, all right, miles driven must be a value between this and this. I got to change that too. So let's make those changes. Okay, and then continue on. So let's see. So inside of here is required must be numeric, must be a value. Name must be a value between this. We don't want it to say non-numeric input. We want it to say out of range input. Okay, so that'll fix that. What else did we have? Well, let's check it. File, save all. So if there's nothing in there, we want to clear. Oh, if there's nothing in there, we have to set the focus. If there is a value in there, we have to set the focus and clear out the value. So let's do both of those. So we'll set the focus here. And in this case, we need another else. And this will be to clear out the text and set the focus. That should now have got everything that we've got in here handled. Let's double check. Okay. All right. So let's do a save all here. Run it again. If there's nothing in here, nothing. Okay. I'm going to put the right there so the cursor's right there. This should give me that message and put the cursor back here. Miles driven required. There's our cursor. We put in something non-numeric and I move on. Non-numeric input. Cleared it and put the cursor there. Finally, if I put in something that's out of range input. Okay, we still have to clear that. All right. And we want to clear that and set the focus. Okay. All right. So is within range. Okay. If keep going, and this should actually be a return here. Okay, otherwise set that and return. Yeah, just like we did there. So if I want to keep going here, what do I want to do? Well, now I want to come in and say keep going. Now I know I've got a valid value for my miles. All right, so I can say miles driven equal decimal dot parse txt miles driven dot text. All right. Now I can say keep going equal, and now I'm going to run the same tests, but I'm going to run them on the gallons used field. All right. So just like we did before. In fact, I should be able to come in here and copy all this stuff and then make some changes. We'll see. See if it works or not. All right. So let's see. I'm going to start it. No, I'm not. That's too much to be typing. So let me just put in this. But this is now no longer miles driven. It is gallons used here. And it's TXT, gallons used here. All right, so that's that one. Now, else. Again, we'll want to come in and clear out the value that's in there. TXT miles driven dot text equals nothing. And the focus. Okay, we're actually using that twice, so we could write a method to do that too if we wanted to. Okay, all right, so we've got all that. Now I'm going to do this one. But again, make my changes. So if keep going, I don't want to do the is within range yet. So I screwed up there, sorry. So let's bring that back up. So there's is decimal, that's what we want. All right, now we can come back and find my one within the is within range here. This becomes min gals, I think I called it, and max gals. All right. So what do we have here? Otherwise, again, this is going to be that and that. And then finally, hold on a moment. All right, hopefully I've got all these administrative things on the last day of class out of the way. So we've got this if keep going. Yeah, now we can set gallons used. Good golly, come on. So gallons used is equal to that of it's right there. Okay, there is no more keep going here. So if that's the case, I want to call calculate MPG, and I want to pass in miles driven, and I want to pass in gallons used. And then finally, we're going to call display. No, display all. And I want to pass into that miles driven, gallons used, and MPG. All right. So this is going to be gallons used equal that. This will be MPG equal that. And I don't know if I created an MPG, but I am right here. Decimal MPG equals 0.0 M. Okay. All right. So these haven't been written yet. So what doesn't it like here? The name gallons used does not exist in the current context. Well, there's gallons used. I'm not sure why it doesn't exist, but we'll have to figure that out in a minute. Let's write this. So this is our this will return a decimal, and it's calculate MPG, and it'll be passed in this decimal value, and it'll be passed in this decimal value, and it will return miles driven divided by gallons used. Okay, no, there's still something there. Now it's happy with everything. That's good. Got to figure out why it's giving me that error, but and I've got to do this display all here. I got to write this. And again, these are all decimal. Okay, and we want to put that into here. So the only thing we really need to be providing there is the miles per gallon. So I don't need to really even pass in, as I'm doing right now, I don't need to pass in the miles driven or the gallons used, just the MPG. So we'll fix that down at the bottom, and then we'll try to figure out that other error. So display all we need here is a decimal with the MPG. All right, so that is the other txt MPG dot text equals MPG dot to string, but we'll put it as an N2. All right. So there's one error we still have in here. That is this. Why doesn't it recognize that right there? Name gallons used. Generate field gallons. We already have the gallons used. It's right here. 2, 3, 4, 5. Just keep going. All right, took it there. All right, longer program than I thought it'd be. It's upwards of 200 lines. But now let's see. I could have missed something. There's all sorts of problems there could be in here. All right, but let's take a look. If I put nothing in there, required field missing, miles driven is a required field. That's good, and there's the cursor. If I put in something non-numeric input, miles driven must be a numeric value, cleared, and then it's our cursor there. Put in something that's out of range, miles driven must be between 1 and 1,000. Well, that's wrong. We'll fix that in just a moment. And we'll try doing it the other way. All right, we just have, let's fix that right away. We have miles driven. Why is it putting under gallons used? Not good. Well, let's put in a valid value here. 345. String was not in a correct format. This is wrong. Okay, boom. Is something is goofed up with the order here. Is decimal for miles driven. Is within range for miles driven. Is present for miles driven. Those are all there. All right, if I get down to here, this is miles driven. This is not gallons used here. Okay, so that'll fix that. Stop the run here. All right. Then where are all my other ones? What the heck happened here? This is not right. That's got to be removed. So if keep going, miles driven equals decimal dot parse. And keep going is going to be equal to is present otherwise. Okay, so if this worked, is decimal gallons used, otherwise clear it. And is it otherwise clear it? Now I can put that stuff in, and I can say gallons used is equal to decimal.parse txt gallons used dot text. All right, it may be finished. So file, save all. Nothing. Required field, and there it is. And there it is. And there it is. It's still wrong right there. So let's fix that last one there, and then we'll come back again. It's within range. Otherwise, if keep going. It should be doing this, and it's putting it in the wrong field. Well, let's see what happens if we put in two valid values. That is correct. Okay, that's working. Now, what I want to do, because I foolishly didn't do it like this, I'm already at 1 hour and 3 minutes, so I'm going to stop. But I'm going to rewrite this again. But instead of having it the way we have it, all right, I'm going to go back and rewrite all of this. Okay, I'm going to rewrite every bit of it, but I'm going to rewrite it and use try catch. So I'll be back to do that in just a couple minutes.